Hello, my name is Avinash Ganta, and in this video we'll talk about the Java heap area and the issues related to it. We will specifically be focusing on troubleshooting these issues. The agenda for the video is we'll talk about some concepts related to Java memory management, and then I'll talk about the out of memory error, which is the key error in these issues. We'll go through some basic troubleshooting steps that can be performed to resolve these issues, and then we'll go ahead and talk about some advanced troubleshooting steps for the same. So first, some basics of the Java memory management module. The memory occupied by a Java process can be divided into different areas. The part where objects created by the Java program reside is called the object heap or simply heap. The size of heap can grow or shrink during the runtime of the Java program. The JVM provides several command line options that control the behavior of the heap. Two important settings are the "-xms" and the "-xmx". The XMS determines the initial and minimum size of the heap. The XMX determines the maximum size to which the heap can grow. In Java, unlike in earlier programming languages like C and C++, the memory occupied by the objects that are no longer required by the program are automatically reclaimed. This activity is called garbage collection. The garbage collection procedure is triggered when certain conditions are met. For example, the heap is fully occupied and a new object needs to be created. We'll move on to out of memory error. This is the error that the Java virtual machine throws when a memory allocation request cannot be satisfied. This is normally after the garbage collector is run. The exact error is java.lang.outofmemory error. The most common outcome of this error is that the Java program goes down unexpectedly, and the Java process on the OS is also shut down. In some rare situations, the Java program may also enter a prolonged hung state, where the Java process exists on the OS but does not do any useful work. So let's talk about two common scenarios that cause an out of memory error. The first is the genuine memory requirement is not met, and the second is the case of an object leak. The genuine memory requirement not met use case assumes a Java program has been running for a while and currently has only those objects that are in use and required. Now a new object needs to be created, which would require some heap memory. If the Java process fails to allocate memory for this new object, it throws an out of memory error. This is a scenario where a genuine memory requirement is not met. For example, consider a Java web application, and currently 1000 users are logged in. The basic information of these 1000 users are loaded into the Java virtual machine by creating objects in the Java memory heap. If the heap is currently full because of these 1000 users and a new user logs in, this can lead to an out of memory error. So this issue is where a genuine memory requirement is not met by the JVM. The solution to such issues is normally related to Java memory tuning options. For example, increasing the XMX value. The other scenario is that of an object leak. In the previous example, let's say the Java web application is faulty and it continues to hold references to objects related to users who have already logged out of the application. So in this case, if a new user tries to log in and the Java process is not able to fetch any memory from the heap, this goes out of memory and the new user login will lead to the program failure. So this situation can be described as an object leak. To fix this situation, the Java program must be redesigned or bugs must be fixed to ensure only required objects are held in the Java process's memory. To troubleshoot out of memory issues, the first step is to identify the Java process which is affected. There may be multiple Java processes started by an application. Based on the log messages and with basic knowledge of the application architecture, the process that is failing can be identified. One way is to find out if any expected Java process is not currently running on the machine. Once identified, check the log files corresponding to this Java process. Make a note of the detailed message besides the out of memory error. For example, Java heap space or GC overhead limit exceeded. This gives an indication of what caused the error and is critical information for troubleshooting. The next step is to search for known issues or known configuration changes related to this Java process. So search the Informatica knowledge base articles with the error message and the use case and check if there are any recommendations for Java memory tuning. For example, if the XMS is to be increased. If so, implement the recommendations in the knowledge base articles, restart the application and perform the same activity again. If the issue continues even after implementing the recommendations, perform these advanced troubleshooting steps. Advanced troubleshooting of an out of memory error primarily involves analyzing the heap dump file. The heap dump file has an extension of .hprof and it is created by the Java process. First, verify that heap dump generation is enabled for the Java process. The flag heap dump on out of memory error must be set. Optionally, heap dump path may be set to specify a location for the .hprof files. If these flags are not set, edit the JVM options for the failing Java process and add these flags. In case of AIX operating system, additionally, follow KB 219870 and enable core dump generation. In some cases, along with the heap prof file, garbage collection logging may also be required. If so, follow KB 158146 and set additional JVM flags to enable garbage collection logging. Once all these JVM flags are set, start the Java application and perform the activity that leads to an out of memory error. Then collect these logs and send them to Informatica Global Customer Support for analysis. The application log where out of memory is logged, the .hprof file which has the naming convention java underscore PID, the PID itself, and .hprof. The location of the file is the one that is specified by the setting heap dump path, or the default location is the current working directory of the Java process. The third item is the garbage collection logs if they were configured. And fourth, in case of AIX, also collect the core dump file that was enabled. So these basic steps can be used in any out of memory error issues. To learn more about memory leaks in general, go through this Oracle Tech Note. In addition, information about the Memory Analyzer tool or MAT can be found in this link. We would like to hear from you. Please share any feedback at supportvideos@informatica.com or share them on Twitter, twitter.com/infasupport.